Section 2D, graphing linear equations and inequalities. Equations and inequalities. Two things we're going to look at. We have to use the slope-intercept method of graphing. Unlike before where we used a table, here we're going to graph in something that's considered a much faster method. So we're going to start with number 31. So we know that when you have a line in slope-intercept form, you can use that information to help you graph. This equation has a y-intercept of 5. That's one coordinate, 1 point. Now to graph a line we need at least 2 points. So from that point we're going to use the slope. I'm going to apply the negative to the numerator, so it's negative 8 over 3. Which means from my y-intercept I'm going to go down 8 and that's my rise, negative 8, and my run is positive 3, so I go to the right 3, and that is my second coordinate. Connect the dots, and it's graphed. Much faster than using an XY table, but again you have to properly interpret what's your y-intercept and what's your slope. Sometimes the equation is not ready, so you have to properly solve for y to put it in slope-intercept form so you can graph with that method. So I'm going to go through the process of solving for y. I subtract 4x from both sides. I will finish by dividing by a negative 5. Everything gets divided by a negative 5, very important part of the process here. And when you do that, you'll have y equals this fraction. Negative divided by negative is a positive, so 4/5 x. And then you have to remember to do this part as well, because everything's being divided by negative 5, and that will give us a negative 4. So our graph has a y-intercept at negative 4, has a slope of 4/5, so the rise is up 4, and a run of 5. That's where 5 would be. And that's our second coordinate, and we connect the dots. And that's the graph of that equation using slope-intercept form. Now sometimes, so we're going to look at 47. Now inequalities are graphed the same way with a couple exceptions. Get my nice little graph here. My y-intercept is negative 4. That has not changed. That step is still the same. My slope is 7, which we need rise over run, so I put it as a fraction. 7 is 7 over 1. Rise is 7, run is 1. So 1, 2, 3, 4, 5, 6, 7. Up 7, rise 1. Or excuse me, run of 1. Puts a point there. Now here's where inequalities change. I have to decide if my line is going to be solid or dotted. If I have an inequality that has a line under it, then I have a solid line. If I have an inequality without a line on it, underneath it, it is dotted. So in this case, since there is a line under the inequality, my line is solid. The last part is shading. Notice that I have the left side and the right side of my line that I drew, and we have to decide which one to shade. There's two ways to do this. The simplest way is to describe it this way. The y-axis is your vertical, and your x-axis is the horizontal. What y values, they're wondering this right here, what y values are less than or equal to the line you drew? Well, the y-axis gets bigger values as you go up and smaller as you go down. Therefore, greater as you go up, less than as you go down. So since they want the y values that are less than the line we drew, we will shade downward. There's another way to do that by plugging in a coordinate, and if you'd like to know that method, let me know. Again, we have a scenario where if you do not have it solved for y, you have to solve it for y. Again, it's very similar to regular equations with one catch. Notice that we have a negative here in front of the y, so I'm going to have to divide by a -1. Over here, everything gets divided by -1. And we get y on the left side. On the right side, each piece gets divided, if you remember, and that's a positive 3x now. -1 divided by -1 is a positive 1. But here's where the catch is. When you divide, as you solve for y, if you divide by a negative number, you can divide and you're okay, but if it happens to be negative, you have to switch the inequality so it points the other way. Again, if you divide by a positive, it's not a big deal and nothing changes. But if you divide by a negative with an inequality, you have to change the inequality and point it the opposite direction. So here we graph it with a y-intercept of 1, a slope of 3 over 1, so a rise of 3, 1, 2, 3, and a run of 1. So our next coordinate is right here. There is a line under the inequality, so it's solid. It's a less than inequality, so we would shade below. And that's it for graphing linear equations and inequalities.